Hello everyone, welcome back to online video tutorial on hydrology and irrigation engineering. So in this class we are discussing on the measurement of precipitation. So let us just discuss the introduction, how we are going to measure the precipitation. So as we know, like rainfall is measured based on the vertical depth. So we are going to measure rainfall in terms of depth of water accumulated on the level surface during an interval of time. Okay. So if all the rainfall remained where it fell, okay. So usually, so rainfall is or the precipitation is measured in terms of depth of water accumulated on the level surface. And here, okay, so the rainfall records, it has an history of so many years, so you can see the records of rainfall in India kept, in the 4th century, that is before Christ. So from the 4th century, that is before Christ, you can see the rainfall record. So it is usually measured in terms of mm, and if it is greater than 1 mm, so it is recorded as a traces. And we have so two types of instruments which is used to measure the rainfall, so which is called a rain gauge. So the instrument which is used to measure the rainfall is called rain gauges. So that rain gauges is classified into recording and non-recording type of rain gauges. So let us just discuss what is recording and what is non-recording type of rain gauges. So before that, going to the the measurement by recording and non-recording type of rain gauge. So there are some difficulties which you while you are measuring the precipitation in the field, so you're going to face. So the instrument should be kept above ground surface, so to avoid the splashing of water. Okay, so from the surrounding, and also so to avoid the flooding and accidents, so you have to keep above the ground surface. The instrument should be kept above the ground surface, and the measurement is never subjected to check by repetition. So that is also one of the difficulty, that will give you a wrong result. So you should check for repetition, but that is not going to do so in case of rain gauges. And in urban areas, it is difficult to locate the site to be free from effect of wind and obstruction, so where it will affect the recording of rainfall. So those are some difficulties which we are going to face. And let us just discuss how to measure the precipitation using non-recording rain gauge. See, the standard non-recording rain gauge, which is prescribed by the IMD, that is Indian Meteorological Department, is a Simon's rain gauge. Okay, so here it gives the total rainfall that has occurred at a particular period. So it will give you the total rainfall occurred at a particular period. So it consists of funnel with a sharp edge rim. So as you see here, so you can see the funnel, it has a metal container and collecting bottle is there, and the funnel with a sharp edge rim. So this is the rim, so which is of 127 mm in diameter. So in the figure itself you can see, and you have metal container, collecting bottle, or it is also called as the receiver. And so the funnel and the receiver, so you can see both funnel and the receiver are kept inside the metallic container. So in the figure itself you can see both are kept inside the metallic container, and the gauge is kept on a masonry. You can see, so the rain gauge is kept on a masonry or a concrete block, okay, or a concrete foundation. Okay, it is kept on a concrete foundation, so which has a size of 60 by 60 by 60 centimeter, and it is sunk into the ground. So means we are submerging inside the ground, and the base of the gauge is cemented into the foundation, so in the figure, so that 30 centimeter above ground level. So you can see here, so you should keep the base of the gauge. You can see this is a base of the gauge. So this base of the gauge is above 30 centimeter from the ground level. So that is how you have to cement the, so that is how you have to install the gauge. And you can see the components of the gauges, this non-recording, that is Simon's rain gauge. You have funnel, metal container, collecting bottle, the diameter of the funnel, and which is placed on concrete foundation. So let us see what is the procedure to measure the rainfall. So first, and also you should make sure that collecting tank, whatever this collecting tank is there, so that should be protected from radiation, or else so there will be a loss through evaporation. To avoid the evaporation losses, it should be kept, it should be protected from the radiation. And also to prevent the rain from splashing in and out. Okay, so to prevent the splashing of water in and out, so the vertical wall of sharp edge rim is made so deep. Okay, and the slope of the funnel is kept at least 45 degrees. So you can see the slope is usually kept at 45 degree. And what happens once the rainfall falls? So it will fall onto the funnel, okay, and is collected in the collecting tank or a receiver. So through the funnel, so it will get collected in the collecting tank, or it will be received by the receiver. So the water collected in the receiving bottle is measured by a graduated measuring jar. So what we are going to do once it gets collected, so we are going to remove the collecting bottle, and using a measuring jar which has a capacity of 25 mm, so we are going to measure how much depth of water has been collected in the collecting bottle. So with an accuracy of 0.1 ml. So whatever the measuring jar with a capacity of 25 mm and accuracy with an accuracy of 0.1 ml, so we are going to measure the water collected in the collecting bottle. So and the receiver capacity, it's around 175 mm of rain. So the capacity of receiver is 175 mm rain. And during the heavy rain season, so we are going to use the rain gauge with the capacity of 375 mm or 1000 mm. So receiver capacity. So during heavy region, so we cannot use this 175 mm of receiver capacity. So in that case, we are going to go for a larger capacity of receiver. And also, so in IMD, so that is Indian Meteorological Department, recently, so they have started using this fiberglass reinforced polyester rain gauges, okay, so which are available in different combinations, like of different receiver capacity, different collector areas. So based on that different receivers, so you will get this fiberglass reinforced polyester rain gauges also, where you can use that to measure the rainfall value. So where this has a capacity to record the depth of 100 to 1000 mm. So these fiberglass reinforced rain gauges have a capacity to record 100 to 1000 mm of water rainfall, and that this rain gauge is conforms to IS 5225 1969, and you can get the details of complete rain gauges so in this IS code, that is IS 5225. And also at a routine time of observation, the funnel is removed and the receiver is taken out, okay, and the collected rainwater. So what we are going to do, so once the the rainfall gets started, once the rainfall started, so then the rainfall gets collected through the funnel, and through the funnel it is received by the receiver. And after that, so we are going to remove the receiver, and carefully we are going to pour that collected water into the measuring glass, okay, and also we are going to read how much depth of water has been recorded. And while reading, so there should be no error, okay, so there should not be any parallax errors. So these are some, the Indian standard rain gauges, like the collector and the receiver. So this some of the standard rain gauges of collector and receiver, so which are available to measure the rainfall. And here the rainfall is measured every day at 8:30 a.m. That is according to the Indian standard timing. So 8:30 a.m. and the measured rainfall in the 24 hours ending with 8:30 a.m. is recorded as the rainfall of the day on which the observation is taken. For example, if you are recording today 8:30 a.m. means so that depth of rainfall will become the rainfall of that particular day on which day you are measuring the data. If you are measuring today, that will become the rainfall of that particular day. Okay, but it will give you the past 24 hours data. And also during heavy rains, what happens? So you have to measure the rainfall 2 or 3 times a day, because obviously rainfall is heavy. You need to measure it 3 or 4 times a day, and thus this Simon rain gauge gives only the total depth of rainfall for previous 24 hours. So as I have already mentioned, like it will give you the previous 24 hours data, and it will does not provide the intensity, duration of rainfall during different time intervals of day. So it won't give you how much intensity of rainfall has been occurred and in which duration it how much quantity has been occurred. So that intensity and duration is not available from this non-recording rain gauge. And the second type of rain gauge which is used is a recording type of rain gauges. So in this, what happens, as I've already told, non-recording rain gauge will only give the depth of rainfall which is recorded for previous 24 hours, but it won't give the intensity of rainfall and duration and when the rainfall has been started, when it is ended, and how it has been varied with respect to duration. All those data you won't get it from the non-recording rain gauges. So in order to record that when the rainfall has been started, when it has been ended, and what is the intensity of rainfall, and also a continuous record of rainfall, that is nothing but the variation of rainfall with respect to time. Okay, so all that is required. Okay, so for that we are going to use the recording type of rain gauges. To get the continuous data, we are using a recording rain gauges. And this usually the recording rain gauges will work by a clock driven drum, so which carries a graph, okay, with a pen, so where that will record the cumulative depth of rainfall continuously. Okay, under this recording you have different rain gauges like tipping bucket, weighing bucket, float type with the siphon arrangement. So let us just discuss one of the type of recording rain gauge, that is a siphon or a float type rain gauge. See, this is also adopted by IMD, and it consists of receiver, funnel, cover, float, siphon chamber, filter, clock driven drum. So these are the components of this rain gauge. And here the filter is also used. So the purpose of filter is to prevent the dust and other particles so that it will enter into the float chamber. So where if the dust and other particles enter to the float chamber, so that will affect the siphon mechanism. So this is basically works on the siphon mechanism. So let us discuss what is siphon mechanism in the later slides. The float chamber will be consist of float with a vertical stem, okay, protruding outside, and the top of which is mounted with a pen resting on the chart graph around the clock driven drum. So I'll show you a figure you can see here. So this is a funnel. So you have a funnel here. So and so this is a base. This is a cover. So this box like structure, that is a cover, and you have a filter here. You can see this is a filter. So to avoid the dust, and after the filter, so it is connected to the float chamber. You can see from the filter water will come to the float chamber. You can see this is a float chamber, and along with the float, so this is a float, and that float chamber is attached to a siphon chamber. So this is a siphon chamber, and this is a siphon. Okay, and this float is attached to a clock driven drum, okay, revolving. So this particular part is a clock driven drum along with the chart and pen. So and you have a clock mechanism here, so where it will record the graph, and these are the dimensions of this siphon recording or a float type recording rain gauge. So let us see what is siphon mechanism, how this is going to record the graph. So float chamber is connected to a compartment with a small opening at the bottom, so which is called a siphon chamber. As you see here, float chamber is connected to a siphon chamber with a small opening. This is a small opening. So this chamber has a small vertical pipe at the bottom. So you can see the siphon has a small vertical pipe. okay, at the bottom. And it is named as a siphon type rain gauge. So as it uses siphon mechanism. So as it uses siphon mechanism, so it is named as siphon type rain gauge. To empty the rainwater. So what is the siphon mechanism? See, siphon mechanism. So this uses siphon mechanism. So to empty the water, so which is collected in the float chamber. Okay. So what happens? See, first I'll tell you here. So once the water enters, so through the funnel, it will pass to the filter. Okay. So after passing to the filter, it will get collected in the float chamber. So once the water gets started collecting in the float chamber, then what happens? This float will move upward. So as float is connected to this, clock driven drum, which is along with the chart and a pen, so it will start moving. So it will start moving and start recording the rainfall data like this. So as it moves upper and upper. So once this, the complete float chamber gets filled up, then that water will go to this siphon chamber. So automatically through this pipe, the water will comes out. The siphon will empty the water. So once the water gets emptied, then what happens? Obviously the float will come down, so that the pen will also come down. So that is how the chart will get entered here. So again, what happens as the rainfall gets collected, it will pass through the funnel, filter, and gets collected in the float chamber. Once again, the process repeats. Like once the float chamber gets filled up, then it will go to the siphon chamber, and siphon will automatically empty the water. And automatically, as the float is connected to this chart and the clock driven drum, so it will record the data. So like this. So that is called the siphon mechanism. So that is how the rainfall is going to record. So the rainwater entering the gauge is led to the float chamber, as I have told, through the funnel and the filter, and the rainwater collected in the float chamber rises the water surface in it along with the float. Okay, so once the rainwater gets collected, it rises up. Float also will rise, and enabling pen to make traces of cumulative depth. So it will automatically draw the depth of rainfall in the chart like this. And so when the float chamber is completely filled with water, what happens? The pen will reach the top of the chart. It will reach the top of the chart like this, and at that point, what happens? The siphon mechanism occurs. That is nothing but automatically through the pipe, which is in the siphon chamber, as I have already showed. So the water will get emptied, and the float chamber is emptied, and the pen is brought on to the original position, that is nothing but 0. So this, as the rain continues, then what happens? Again, the pen will rise, and once it reaches the top of the chart, then the siphon mechanism occurs, and again it will reach to 0. Okay, and this siphoning will take a time of 15 seconds. And here, see, this type of rain gauge record only the precipitation. So it cannot record other than the rain. Because so if you want to record a snow or other forms of precipitation, then what happens? So you have to install some heating device, because the float may get freezes up. So obviously, if float freezes up, so then it won't record any data. So that's why, so this recording rain gauge will record, that is float type rain gauge will record only the rainfall. So this is how the data is going to record in the chart. We can see here. So once the rain gets started collecting, so it will, the pen will start moving. So once it reaches the top of the chart, then siphon mechanism occurs, then it will come back to 0 once again. And once again, once the water gets collected, so again it will rise. So this is a typical chart of rainfall recorded by a float type rain gauge. Thank you all. We'll just see the next topic in the next class.